Hey guys, today we're going to do Unit 6, Lesson 2, which is a continuation of finding quadratic roots. But today we're going to do that by taking square roots and by completing the square. And the things that these have in common is that we will be using square roots for the entire lesson. Okay? So solving a quadratic with square roots is when there is no bx term in the quadratic. So normally it would be ax squared plus bx plus c. Well, this is missing the middle term. And so it's very simple to solve this just by taking a square root. So what we will do is isolate the x squared. It might just be one step by adding or subtracting the c value, or it might include two steps where we would also have to divide by the a value. All right, and then our last step would be to take the square root of both sides and to simplify that square root. So let's look at 5 quick examples of using this method. So I want to isolate this x squared term, so I'm going to add 49 to both sides. So now I have the x squared by itself, and it equals 49. So what I can then do is take the square root of both sides, and I get just x, and I get just 7. Okay? Now here's one key thing that you do need to remember. Whenever you take a square root, it is always going to have 2 possible roots. So I need to put plus and minus, okay? And what that means is that my 2 solutions are a -7 and a +7. I have 2 solutions for this, okay? So let's look at the first official example. To get this x squared by itself, I need to go ahead and subtract 7 from both sides. Subtracting 7, I get x squared equals 81. If I square root both sides, I know that I'm going to get a plus or a minus x, and then the square root of 81 is 9. So my 2 solutions are -9 and +9. Awesome job. Let's look at example 2 where we're going to have to do 2 steps. First, I'm going to add the 108 to both sides. So I have 3x squares equals 108. And then to get that x by itself, I'm going to need to divide everything by 3. So dividing by 3. So now the x squared term is isolated. And then 108 divided by 3 is 36. So let's go ahead now and take our square root. So I've been doing this step in red, okay? So square root, just remember that that gives you both a plus and a minus. The square root of 36 is 6, and that is our 2 solutions. So -6 and +6. All right. Example number 3. Example 3. So I see a -11 here, so I'm going to go ahead and add 11 to both sides. 25 and 11 is 36. And I still have this 1/2 x squared over here. Well, to get rid of the 1/2, I'm going to need to multiply both of sides of the equation by 2. Okay, and so now I have x squared equals 36 times 2, and I'm going to leave it written like that on purpose. I'll show you in just a second. Now I'm ready to take the square root. I will have a plus and I will have a minus. The square root of x squared is x. Now check this out. The square root of 36 is a perfect 6. The square root of 2 cannot be simplified, so it is stuck under the square root symbol. So square root of 2. And so that is my final answer. X equals plus or minus the square root, or 6 square roots of 2. Okay? All right, so this is more of a complicated answer. If you want the exact decimal value, you could just type it into the calculator. And I'm going to leave my answer just like this time. Okay? So you could write your answer in both of these ways, just like we did in our last lesson with the curly braces, or you could leave it like this. All right, and then our last example of simple solving by square roots. Subtract 66 from both sides. 3 minus 66 is a negative 63, and that equals 7x squared. Let's divide both sides by the 7, and I get x squared equals negative 9. And so here's what I'm going to do. I'm going to go ahead and do my square root, but I cannot take a square root of a negative number. Because this is negative, right now I cannot solve it. So I say no solution, or no real solutions. Okay? Again, this doesn't have any real solutions, but it does have some imaginary solutions, and we will learn how to find those imaginary solutions in lesson 5 of this unit. So for now, we're just going to say no real solutions because there's a negative 9 under there. All right? And then, of course, you could always write it like this. Well, a 0 with a line through it. Okay? All right, so that is solving quadratics by taking square roots. Now we're going to look at perfect square trinomials because we can solve these in a similar way. A perfect square trinomial is when you have a perfect square in the front and a perfect square in the back. So let's look at what these squares are. This is 1 times 1, and this is 2 times 2. Okay? Now, if you look up here, b squared, so 2 squared is 4, a squared is 1. So if you multiply a times b, I'd get 1 times 2 is 2, and then multiply it by another 2, because that's part of this little formula, and I would get 4. So this is a perfect square trinomial, all right? And here's how we're going to write that. 1x plus 2 in parentheses squared. I want you to notice that if this original equation has a plus sign right here, when you write it as a perfect square binomial, it will also have a plus sign. So we have x plus 2 squared equals 25. All right? And now we can simply take the square root of both sides. So I've been doing this in red. Let me keep it up. So take the square root of both sides. Now I have a plus or minus still, just like before. And then I have an x plus 2 on this side. And then the square root of 25 is 5. Now I'm not actually done here. I still haven't isolated the x, but I couldn't do anything with the x when it was inside the parentheses with the 2 added to it. So I had to square it first, or square root it first rather. Now I can subtract the 2 from both sides. So minus 2, minus 2. So x equals, and here's what I have. I have positive 5 minus 2 is 3. And I have negative 5 minus 2 is -7. So I have two solutions still. All right. Okay, let's do example number 6. This is another example of a perfect square trinomial. The only difference is that this middle term is a negative. So when I rewrite it as a squared term, it will also be negative. So here's how I do this. The square root of 4 is 2. Bring down the x. The square root of 16 is 4. And then bring down the negative. And that is my perfect square trinomial. If you wanted to do the FOIL method to go backwards and you could just kind of prove to yourself that you did it correctly, 2x times 2x is 4x. 2x times -4 is -8. -4 times 2x is another -8x. So that gives me -8, -8 is -16. And then -4 times -4 is 16. All right. Now we're ready to go ahead and square root both sides to get rid of this squared outside the parenthesis. And so I have 2x minus 4 equals plus or minus the square root of 36 is 6. So I am going to add 4 to both sides. Add 4. And then I will have to divide by 2. So divide everything by 2. Let me use a little sheet of scratch paper really quick, right out to the side here, to show you how I get my two different solutions, okay? So positive 6 plus 4 divided by 2, and then I also have a -6 plus 4 divided by 2. And now I'm ready to simplify each of these. 6 plus 4 is 10 over 2 is a positive 5. -6 plus 4 is a -2 divided by 2 is a -1. So my two solutions are -1, 5. -1, 5. And here's the work for how I got those. So just remember, one is a positive solution, the other is a negative solution, and you have to break those up to figure out what the two solutions will be. Okay, now our next method is going to be by completing the square, but I don't want to jump into examples until you know what it actually means to complete the square. So if I had algebra tiles with you in the classroom, I would kind of demonstrate this for you with some algebra tiles, but I don't. So I did my best to create these images for you. So I have a square, which is x times x, and that gives me x squared. X times x is x squared, okay? Now the length here is still x. So now I have b times x, which is bx, and I'm adding those together. I don't know what the value of c is yet. That's what I'm trying to figure out, is what goes inside this missing box here. So if I take this rectangle B and I divide it in half and then move the other half to the bottom, so here's what I now have. I took the value of B and I divided it in half, and I put the other half on the bottom. Notice that I'm working towards making a new bigger square, and in this bigger square, I need to fill in this tiny little piece that's going to complete it. Okay, so I am completing the square. And what's written right here is b divided by 2 squared. So let's take a look at what this would look like with an actual trinomial, okay? So here's my example. I have 4x squared minus 8x, and I want us to find the value of c. Okay, so I have 4x squared. Well, I want this to be in my square, 4x squared. So in order to do that, I have a square that is 2x times 2x. 2 times 2 is 4, x times x is x squared. Okay? Minus 8x. So this is minus this time 8x. Well, excuse me, that's not x. I'm just using the 8 right now. Okay, so I want to divide this 8 in half. What is 8 divided in half? 8 over 2 is 4. So now this is a 4 and this is a 4. Okay, if you want to bring over your 2x's, you can. So now I have 4 here and 4 here. So I know that I have a 4, okay? And so 4 squared, this is 4 and this is 4. If I filled in this square, it would be 4 by 4, which is 16. And I made it a little bigger so that we could write in it, okay? It is 16. So I end up having 2x minus 4, okay, 2x minus 4, and then if I square that, if I square it, I'll end up finding that 16. So this is the length of 2x minus 4. This is 2x minus 4. And if you did 2x minus 4 squared, again, let me show you my scratch work to kind of prove this. Okay, so 2x minus 4. And if I square it, okay, that's how you find the area of a square. You do the length times the width, and in this case, they're the same measure. 2x minus 4 times 2x minus 4 is 2 times 2 is 4x squared, minus 8x, minus 8x, and then plus, so negative 4 times negative 4 is 16. Okay? And so, yep, there we have it. And so that's where I find the missing value of C is 16. Okay? Alrighty. Let's now jump into just standard examples of using this method to solve. And so here we go. Solving quadratics by completing the square. So notice you see b divided by 2, just like we did here. Let me pull up my picture again. So you still see the same elements here. You see the b divided by 2 and the b divided by 2, and then you see the b divided by 2 squared, the b divided by 2 squared. And this is just my way of helping to keep my work organized. So we're going to be doing this process, but instead of visually, we're going to do it algebraically. Okay, so we are going to, when you complete the square, you are creating a perfect square trinomial, and you're solving it using square roots. So let's go ahead and do this together. Okay, so for example 7, the first step is to rewrite it as ax squared plus bx equals c. So I have my x squared term and I have my x term. I need to go ahead and move over any constant terms to the other side. So let's add 50. Okay, 50 minus 2 is 48. X squared plus 2x is what I have left. Okay, now what I'm going to do is I am going to use this 2. Okay, this is my B term. And so I am going to go ahead and do B divided by 2. So 2 divided by 2 is 1. And then that 1 squared equals 1. And I will end up using both of those numbers, okay? The bottom number tells me what I need to add to both sides. So let me just highlight that here. So this number right here tells me that I need to add that number to both sides, okay? This first number tells me what is going to go inside my binomial. So plus 1. And now I'm going to write this as a binomial squared. And it's going to equal that 48 plus 1 on the other side, which is 49. We've just completed the square. Everything that we did was completing the square. Now we're going to do exactly what we did with our perfect square trinomials. Okay? So I'm going to draw a line. That is completing the square. Completing the square. That's that step. Now, step 4 and 5 is just like what we had to do. I'm sorry, just step 5 is what we did with our perfect square trinomials. Okay? Just step 5. So x plus 1 squared equals 49. I'm going to square root both sides. So I get x plus 1 equals 49. Square root is 7. And don't forget the plus or minus. And now I'm going to subtract 1 from both sides. So I get x equals positive 7 minus 1 is 6. Negative 7 minus 1 is negative 8. Okay, and those are my two solutions. Whew, that might have been a little complicated, but that's okay. Let's do some more examples until we get more comfortable with it. So example 8. First step is to move over any constant terms away. Okay, so I'm going to do that. 4x squared plus 8x equals 5. All right, step 2, which we didn't have to do the first time, we're going to divide the equation by a. So divide everything by 4. I always want the a value to be equal to 1 when I'm doing this. So let's divide everything by 4. Okay, so now I have x squared plus 2x equals 5 over 4. Now I'm going to take the b value. B equals 2. Okay, so 2 divided by 2 is 1, and then 1 squared is 1 again. So here's what I'm going to do. On the left side and the right side, I take the green or the bottom value. After I've squared it, that's what tells me I need to add to both sides. Let me do it this way. 1 over 1, or I'm sorry, adding 1 is the same as 4 over 4. Okay, so I'm going to do it that way since I have a fraction. And then on this side, I also need to add 1. Now I'm ready to factor this perfect square trinomial. This right here is step 3, or step 4, factoring the perfect square trinomial. Let me just underline this in pink because that's what I've highlighted in pink. So I have a positive 1 that's going to go here. Let me underline this in green because that's what I've added to both sides. And so I now have x plus 1 squared equals 5 plus 4 is 9. And then when you're adding fractions, you keep the denominator. So 9 over 4. Now I'm going to do step 5. Take the square root of both sides and solve for both cases. So let me just write this a little neater, guys. I got messy. X plus 1 squared equals 9 over 4. So I'm going to square root both sides. Square root both sides. And now I have x plus 1 equals plus or minus, the square root of 9 is 3, the square root of 4 is 2. And now I'm ready to add the 1 to both sides, or actually subtracting 1. Subtracting 1. So let's change this 1 to a 2 over 2, okay? So positive 3 minus 2 is 1. Positive 1 over 2. And then negative 3 minus 2 is negative 5 over 2. And those are my two rational solutions, okay? They are fractions. Let's take a look at number 9. Number 9. So I need to go ahead and rearrange this so that everything is where it belongs. So let's add this x squared to the 3x squared. And then bring down minus 24x. And then let's add this 44 to the 1 to get 45. Okay? So I added 1x squared and to both sides. And I added 44 to both sides. So on this side, this canceled. And on this side, this canceled. Okay. Now I'm ready to divide everything by 4. Divide everything by 4. So that is step 2. Maybe I need to highlight step 2 in yellow. You only need to do that when the a value is not equal to 1, okay? So I highlighted that in yellow. When the a value is not equal to 1. So divide everything by 4, 4, and 4. So this is x squared minus 6x equals. Now we're going to go ahead and b equals negative 6 in this problem. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So what I need to add to both sides of my equation is 9. Okay. And now I'm ready to go ahead and write this as the perfect square. So this will be negative 3 inside here. So I have x minus 3 squared equals, and let's simplify this. I'm going to get 81 over 4, guys. I'm just going to save us a little bit of math. Okay, it's going to equal 81 over 4. All right, and now I'm ready to simplify this by taking square roots. Alrighty, and so now what I'm going to do is add 3 to both sides. Okay, so add 3 to both sides, which would be the same as adding, let's see, is that 6 over 2? So x is going to equal, okay, 9 plus 6 is 15 halves, or negative 9 plus 6 is negative 3 halves. And those are my 2 solutions. All right, let's take a look at 2 examples where we have irrational solutions. So I said these are rational, both of them, because they have fractions that end, right? They would just be a 0.5 because they're both divisible by 2. So now let us look at example 10. Okay, same rules apply. I need to go ahead and rearrange this so that it is in ax squared plus bx form. So subtract the 6x and then add the 2. Okay, so this is what I have. Now I'm going to take the b term. I don't have to divide by a this time. I'm going to take the b term, which is negative 6. And so I will get a negative 3 and I will get a positive 9. So again, in green, I'm going to add 9 to both sides. Add 9, add 9. And so when I write this out as a perfect square, negative 1 plus 9 is 8. And then I'm going to get x minus 3 inside my parenthesis. Okay, let's go ahead and solve this by taking square roots. Okay, so I'm going to go ahead and rewrite 8 as 4 times 2, where the square root of 4 equals 2, and the square root of 2 equals still the square root of 2. I can't simplify that. So here's what I have when I do x minus 3 equals plus or minus 2 square roots of 2. And now I'm going to go ahead and add 3 to both sides. And now this doesn't look very pretty, but here's how we're going to write our answer. X equals 3 plus or minus 2 square roots of 2. And that is our irrational solution. And we're going to leave it just like that. It does represent 2 separate answers. Last example, number 11. We're going to do the same thing. Okay. Add 4 to both sides. Now I need to, because my a value is a 5, I need to divide everything by that 5. Okay. So now I have x squared plus 6x equals 4. Now I'm going to go ahead and take half of my b value. B is 6. So half of that is 3. Square that is 9. So I'm going to add 9 to both sides. Add 9 to both sides. And then go ahead and write out my perfect square, which will be x equals 9 plus 4 is 13. And inside here will be our plus 3. I am now ready to square root both sides. Okay. Well, the square root of 13 does not simplify, so I'm left with plus or minus the square root of 13. And then x plus 3. So let's subtract 3 from both sides, and here's what our answer will look like. Negative 3 plus or minus the square root of 13. And I'm trying to do squiggly braces, but I'm really butchering them today. Okay, so that is my second example of an irrational solution. And if you type that in the calculator, that's going to be a decimal that continues on and on and on forever and ever and ever. Okay. All right, kiddos. And then the only thing I had forgotten to do here was to mark out. So green is what I'm adding to both sides. Pink is what goes inside my perfect square binomial. Okay. Yellow is if the A is greater than 1, then I need to divide by it. So I've highlighted everything here for us. Okay. And then take the square root of both sides and simplify completely and solve for both cases. So these are my steps. All right, kiddos. So today what we did was we solved quadratics to find the roots by both just taking a simple square root, by solving perfect square trinomials, and then by creating perfect square trinomials and then square rooting. Okay, so the theme for today was everything that you can solve by taking a square root, pretty much. Okay, so that is our lesson for today. Be sure that you get plenty of practice in, and until next time.